Hey guys, welcome back to the shop. My name is Paul, and we're continuing our hydraulic series here. The whole series is called Hydraulic System Inspection and Troubleshooting, and we've broken this down into 4 sessions. So this is session 2. So what we're going to be talking about in this session is component operation and how they fail. And I've got some failed components here that I'm going to show you while I'm doing this. And so hopefully it'll make it interesting rather than just, running my mouth the whole time. So the first thing we want to talk about is the hydraulic reservoir. A lot of people think that the hydraulic reservoir is just dumb and square and holds oil, but it really does several other things. I want to make sure that people understand that. The function of a hydraulic reservoir is it holds the system fluid supply, it transfers heat through the walls, it allows bubbles to rise to the top. When the oil comes back, it's very turbulent and it's got air bubbles mixed in with it, so it allows the air bubbles to rise to the top. And when the oil comes back, it's got contamination mixed in with it, and it allows the contamination to fall to the bottom. So the reservoir does lots of things, so just making sure people understand that. Alright, how they fail is leaks, obviously, is a safety hazard. Clogged breathers. There's a breather that's up here on top of the reservoir, and what I've got is one of these breathers actually taken apart so you can see the things that happen inside of that breather. This is just a piece of foam, so you'll see those breathers are basically garbage. Okay, so they don't catch very much. The things that I need to protect this pump from are down in the 3 micron level, and this definitely isn't 3 microns. Okay, so if you see one of these silver breathers on top of your system, it basically isn't doing very much. Okay, so one of the things we do recommend is a heavy-duty breather. Okay, so what this does, it catches particulates as well as moisture, and some popular brands are Eaton Vickers, and Descase is another popular brand that catches particles as well as moisture. So anyway, make sure you have a good breather, because that's where your #1 ingression point for all your foreign materials coming into your system is through that breather. And by the way, contamination is the #1 cause of failure in all of hydraulics. So if you can protect your system from getting contamination in it, you'll be miles ahead. Okay? Next thing we'll talk about is the hydraulic oil. Hydraulic oil is actually inside the tank, obviously. So hydraulic oil does lots of things. It lubricates your internal components. It acts as a sealant. And a lot of people don't realize that oil actually seals these different components right here. If you look inside this valve right here, you see these little cuts in these lands right here. Okay, so this is your spool inside of a directional valve. This is your pressure port right here. This is your A and B work ports right here, and then out here is your return line back to the tank. Okay, so as this valve shifts back and forth, it has to be lubricated. Okay, so that oil lubricates that spool as it moves, and also seals this P line from the A and the B line right here with these little small orifices right here. Okay, so that oil acts as a sealant as well, so that's important to understand. Alright, the other thing oil does is acts as an energy transfer device. Okay, so oil is incompressible, so whenever you fill up the back of the cylinder right here and it actually pushes out, that's because of the incompressibility of oil. Okay, so a couple of things how oil can fail is be too cold. You noticed this morning when we started this thing up, it was cold. So you see all that vacuum right there on that vacuum gauge? The reason you see all that vacuum is because the oil's cold right now, okay? It's not up to operating temperature. So you always have to have a vacuum gauge in this line right here on your pump inlet to make absolutely sure you're not cavitating your pump, okay? Alright, next thing we want to talk about is your prime mover, which is your electric motor right here, okay? Your electric motor's job is to turn your pump the right RPM to make sure you get the right amount of discharge gallons per minute through this right here. Alright, you see I got 1.8 gallons per minute. That's because my motor is turning at 1800 RPMs and it's turning my pump at 1800 RPMs, and the displacement inside this pump right here is the right amount where I'll get 1.8 gallons per minute through this flow meter right here. Okay? So that's a prime mover's job, is to make sure the pump turns. Okay? So a couple of things, failure modes of your electric motor. Your bearings can go bad inside your electric motor, obviously. When you're in startup condition, you can turn the wrong rotation. It's supposed to turn right-hand rotation, and it can turn left-hand rotation if you wire it wrong. Alright. Misalignment. If you misalign the shaft of this pump right here, you can pull air in through that shaft seal right there, and you can damage your pump. So misalignment is very important. Soft foot, obviously, back here on your electric motor. And then your RPM going too fast or too slow. That can affect your gallons per minute coming out of your pump. Alright, that's your prime mover. Next thing we want to talk about is the pump. Pump is the heart of the system, and 99.9% of the times when your pump fails, it has nothing to do with your pump. It's something that happened in the system, like contamination or cavitation or aeration or things like that we're going to talk about in our troubleshooting and inspection part. So this is called a cartridge kit, and this has your vanes in it. Like inside this pump right here, you would have one of these cartridge kits, okay? And inside this cartridge kit, this little ring right here, this is your ring and your rotor with your vanes in it right here. And so what happens is that thing spins around and your vanes contact this ring right here, and that's how you pump fluid. You've got an increasing and decreasing part of this ring right here, so that's how you pump your fluid in and out of this pump. Okay? So how that thing fails, your pump, is when you cavitate it, you get these nice little divots right here, these little chatter marks inside your ring. So when you fail a hydraulic pump, take it apart next time and see what the ring looks like on your vane pump right here. Those little chatter marks right there says that I've got some cavitation problems. Okay? Alright, on a piston pump, this is called your rotating group right here on your piston pump, and you see your nice little pretty shoes right there, your little brass shoes that spin around on the inside of your pump. Alright, I don't know if you can see this, I know it's hard to see, but right there in the middle of this piston is how it gets lubricated. Okay? And here's a larger version of that, so hopefully you can see that. That little tiny hole right there in the middle of this piston is how it lubricates itself as it spins around on that, what's called a swash plate. Okay? When you starve your pump for fluid, that oil doesn't come through that little hole right there, and you get what's called cavitation. Okay? And as your pump cavitates, this is what happens to it. Those little pretty brass shoes melt. Okay? So as those brass shoes melt and disintegrate, obviously all that metal right there is going somewhere, and it goes out into your system and starts getting into your valves and actuators and your seals and all that sort of stuff. Alright, so when those pieces come apart like that, it actually, this piston right here, the shoe came off and actually dug into this plate right here. as it was spinning around on here, and that's the reason that it finally failed. Okay, so it's important to understand what cavitation, aeration, and those things do to your system. Very, very damaging to your system. All right, let's hear what that sounds like. What we want to do is show what cavitation and aeration sound like in a hydraulic pump, so you'll know what to be listening for. And the way this little demonstration unit is designed is so I can show, this lets air in right here, and this actually shuts my flow off right here from my pump, and you can hear what those things sound like. You want to do that? Adam's going to demonstrate that. What he's going to do first of all is start shutting this. What he's going to do first of all is start shutting this valve off a little at a time, and what you're going to see is little vapor cavities start forming in this hose right here. And what I'm doing is starving the fluid into this pump, and the oil actually starts boiling. That's those little vapor cavities you're going to see right here. So I'm going to get Adam, if he doesn't mind, to shut that off. Alright, you hear that? See those vapor cavities right there? That's what cavitation sounds like. Alright, so that's kind of neat. Alright, so now what we're going to do is aerate this pump and show you what aeration looks like and sounds like. And he's going to open this valve right here and let some air in the system. Alright, you see my flow is dropping off right here. My flow is dropping off right here. And the reason my flow is dropping off is because, remember I told you oil is incompressible? Alright, what I've done now is add air into my oil, and you see all this foamy stuff right here? Alright, that's because the oil is now mixed with air, and my oil has become compressible. So that's the reason my flow dropped off. Alright, this pump now is not pumping oil anymore, it's trying to pump air, so it just stops pumping. And you see your flow drop off right here. Alright, the next component we're going to talk about on the system here is your safety relief valve. What a safety relief valve does is protects your system from overpressurization. Okay, this pump right here is called a positive displacement pump, and it will pump up to whatever pressure this thing will go to until it finds the weakest link. If it's the electric motor, it'll kick the electric motor out. If it's a hose, it'll rupture the hose. I've seen actual bodies right here of your pump housing right here blow up. So if you don't have a safety relief valve in a hydraulic system and you get a clog somewhere, it's going to go, the pressure will go as high as it wants to, okay, until it finds the weakest link. Alright, so some of the failure modes on a pressure relief valve is contamination. When it gets contamination in there, you have a spring inside there that moves back and forth, and it doesn't move very well whenever it gets contamination in it. Another one is heat. As your system heats up, these spools inside of here and even over here on your directional valve will start sticking. So if you got things sticking in your hydraulic system, that is because your oil is oxidized, and it'll start turning a dark color right there. You see this is a real light color, an amber color. Alright, when it starts turning dark, that means you got heat in your system and that oil is oxidizing, and that actually tells your spools inside here to start sticking. Okay? The next one is any mechanical device. You have springs inside these mechanical devices like your relief valve that go back and forth every day. So with that mechanical motion over some period of time, that is going to break. Okay, so a relief valve over a period of time, as it opens and closes, and on your directional valve here, as it moves back and forth, those springs over a period of time are going to break. So that, just expect that. The biggest one failure that I have with these relief valves right here are the wrong pressure range. All right, if I'm going to operate my hydraulic system at, say, 1500 psi, and I get a relief valve that goes from 0 to 800 psi, what's going to happen is every time you turn that system on, your fluid's going to dump over your relief valve, and nothing's ever going to happen out here. Okay? So very important to make sure your spring range is correct on your relief valve. All right, the next thing we're going to talk about is the filtration. Filtration is very important. Chevron did a study and determined that 75% of all hydraulic system failures are directly related to bad oil, dirty oil. So if you can add the right filters in the right places and get that dirt out of there, you'll be miles ahead. All right? You know, I mentioned earlier about your breather. That's all you have in these little silver breathers right here. There's this little foam garbage. Okay? Use a nice breather. I'm not saying use Vickers, I'm just using this as an example. Use a nice breather that can take particulates out of your airborne system. How a filter works is your fluid comes into the filter and goes on the outside of the filter media and pushes it through the filter media and comes in through the middle of the filter and out through the discharge over here. All right, in the top of this filter housing, you obviously can't see that here. We're going to pull a picture in to show you that. Is you have a spring that's called a bypass spring. Okay, and as that filter media gets clogged up, that spring pushes open and your fluid starts going straight through your filter and nothing gets filtered. So it's very important to make sure you have a bypass indicator on your filter, which I have it on there, but it's very difficult to see because it's way up under there. Okay? The next component we talked about is your directional valve. Okay? Your directional valve, here's a nice little demonstration of how a directional valve works. You energize the coil on either end of this spool, and it has a push pin that pushes the spool over to the left or to the right. And as I mentioned earlier, here's your pressure port, here's your A port, your B port, and then your tank ports are on either end right here. Okay? Oh, sorry, right here and here. All right, so when I energize this valve, it opens up my P port to my B port and my tank port to my A port right here, and allows the cylinder to come in and out. All right, when I de-energize it, these big springs like this push the valve back to the center position. All right, when I energize it in the other direction, I've now connected my P port here to my other work port right here, and my other work port here to the tank line. Okay? So that's how a directional valve works as it shifts back and forth. One of the neat things how these things fail is the actual definition of a directional valve is it starts, stops, and controls the direction of flow in your hydraulic system. So one of the biggest things talking about failure modes of these is your oxidized oil I talked about earlier, getting in these orifices right here and keeping this spool from being lubricated, and it gets stuck. And people start trying to beat on them and all kind of things, and it will not move unless you clean it and get it back the way it's supposed to be and change your oil. Okay? One of the things that I often hear when I go in and out of facilities is it's mechanical, no it's electrical, it's mechanical, no it's electrical. All right, on these directional valves right here, this right here is called a manual override. Okay? So at 2 o'clock in the morning, if whatever your actuator isn't moving, you can get a push pin or a little Allen wrench or something and come over here and push that right there in, and it'll manually shift this valve. So if your actuator goes out or your motor starts turning, then that tells you got an electrical problem. Okay? So that's one of the biggest things I run into out there at 2 o'clock in the morning. All right, the next thing we want to talk about is the actuator. These actuators, again, you have a linear that goes in a straight line, and you have a rotary that goes around and around. Okay? If your cylinder is not coming out fast enough, that means you don't have enough flow. Alright, you got 1.8 gallons per minute. We determined a while ago with our little stopwatch that cylinder should come out in 4 seconds. Okay? So if your cylinder starts coming out slower than that, that means you're losing flow somewhere in your system, and you have to go figure out where that is. And the only way to do that is with these flow meters. Okay? We'll talk about that more when we get to the troubleshooting and inspection part, but you have to have these devices in your system to be able to figure out what's going on in any hydraulic system. Alright, same thing when you're with your hydraulic motor. If your motor is turning and it slows down, then you are losing flow in your system somewhere. And again, this pump, you see that it's pumping 1.8 gallons per minute. Alright, so if that drops down to 1.0 gallons per minute, that means something's wrong with my pump. Okay? So it's very important to understand where your flow is going in a hydraulic system. Alright, the next one, we talked a little bit about that just a second ago. My rotary actuator. Again, you go in and out or around and around in a hydraulic system. So if my my hydraulic motor slows down or speeds up, that is a function of flow. Okay, so that's very important to understand that. Then the last one is your fluid conductors, which is your hoses and tubing and fittings and things like that to connect all of these devices together to allow the fluid to move in and out of those properly. Okay, so some of the failure modes that you can experience is overpressurization of your system. I mentioned that earlier, and these things actually blowing up or exploding, these hoses right here. Another one is using a phosphate ester, which is a fire resistant fluid in your system, and you don't change your hoses to a Viton type hose, and your actual hoses will melt. Your O-rings inside of all these components right here will melt. So if you get this weird gray substance in your filters, that means that you're using the wrong kind of oil and it's melting your O-rings inside of all these devices, your sealing devices. Okay? Another one is not being supported properly. You have to have pipe and hose clamps and supports in your hydraulic system, or these things will start rubbing together like this, and you don't want these things rubbing together because they'll start fracturing, and that's the #1 cause of safety problems in hydraulics is slips, trips, and falls and oil injection. So if you have a hose that's rubbing on another one and it starts spraying right here and you walk up there and touch it with your finger, you'll get injected with oil, and we'll talk about that in the safety part. Well, that's the end of session 2. I appreciate you guys sticking with me through that, and I hope you learned something. And next session is inspection and troubleshooting. And what we're going to do in the next session is show you how to set up inspection routes on your hydraulic systems, and we're also going to teach you how to do some troubleshooting tips and tricks for troubleshooting. And what you're going to find out is these are all one and the same. When you start doing inspections and start troubleshooting, it's important to have these devices right here in your system, or you cannot do that properly. Okay? So look forward to seeing you in session 3.